For any main idea question, including ones that are really just about the main point of a paragraph, we don't want to waste our time coming up with our own summary, right? I mean, at most, we might need a dumb summary, something that's very quick and easy. But remember, the point of a multiple choice test is that the answer choices are the summaries. And so rather than come up with your own summary, just use the 4 that are there and test them against what you read. So this is basically what process of elimination is, right? Like it's really just working backwards from the answer choices to better understand the question. So don't waste your time coming up with a summary. Not worth it. But as we read, we're going to try to notice things that are repeated because main ideas are repeated ideas, and anything that jumps out at us might be helpful in sorting through these answer choices. So what do you see? Well, I wasn't around to witness the initial rejection of Higgs' proposal in 1964. Well, I was around, but only barely, so I'm starting to notice here. I can attest that by the late mid-1980s, the assessment had changed. The physics community had, for the most part, fully bought into the idea that there was a Higgs field permeating space. In fact, in a graduate course I took that covered what's known as the standard model of particle physics, the quantum equations physicists have assembled to describe the particles of matter and the dominant forces by which they influence each other, the professor presented the Higgs field with such certainty that for a long while I had no idea it had yet to be established experimentally. On occasion, that happens in physics. Mathematical equations can sometimes tell such a convincing tale, they can seemingly radiate reality so strongly that they become entrenched in the vernacular of working physicists even before there's data to confirm them. So what I noticed was being repeated was the word I, right? This guy is telling a story. So that is something that doesn't happen very often on a science passage, but it's noticeable here because of that. Because it's unusual and it's repeated, I noticed it. So let's look for choices that kind of match with this. He recounts a personal experience, story, to illustrate a characteristic of the discipline of physics. Well, yeah, personal experience matches with story, and characteristic of the discipline of physics, he is telling us at the end that happens in physics. They become entrenched with working physicists even before there's data to confirm them. So, I don't know, this is kind of vague, but I could kind of make it fit with the passage. So it doesn't jump out as being right beyond the story thing, so I can't just like pick it, but I can't eliminate it because I got, you know, the end part seems like it could work. I don't know. Let's look at the other things. He described his own education, true, right? That part's true, to show how physics has changed during his career. Ooh, that's kind of tricky. Now, is he really talking about how physics has changed? Well, he's talking about the way that, here we go, that word changed, right? But the mid-'80s, something had changed. The physics had the community had bought into this idea. Okay, so this maybe works as well. So this seems to match, right? There's this idea of change, and they're certainly talking about his own story. So let's keep that as well. C, he provides autobiographical details, so okay, check, to demonstrate how Higgs' theory was confirmed. Well, no, he does not do that, right? He says that it was confirmed, or it was believed before it was confirmed, right? It had yet to be established experimentally, right? So it has not been confirmed. So this is not a story of how it was confirmed. It's just saying that people tended to believe it. And that's actually kind of like a main theme of the passage, is that this is not something that has been, you know, experimentally confirmed. It's just talking about how it's still accepted anyway. So notice, the first part of this is still true. It matches with my dumb summary. It kind of matches with what we picked out, but it's the second part that doesn't. And so that's why we can't just go by whatever our gut feeling is here, because our gut feeling might notice the good things and ignore the bad. So we're really using process of elimination to look for the bad things in the choices. D, he contrasts the status of Higgs' theory at 2 time periods to reveal how the details of the theory evolved. Well, no, he's not saying, I mean, yeah, it's kind of 2 time periods. It's the beginning, like 64, and then the 80s. But notice that's like in the first sentence, so it's not really about the 2 time periods, really. Reveal how the details of the theory evolved. Well, here's the key piece, is that the theory hasn't changed. What people think of the theory maybe has, but the theory itself is still the theory. So the details of the theory have not really evolved, or at least that's not what he's saying here. So, okay. Those are a lot of similar choices, but now we're down to two, and we really need to think about what are the differences. So when two choices seem like they could both be right, there's a tendency among people to kind of just assume that the SAT is bogus and they're just messing with you, and it's not fair because they both are correct and it's really just a matter of opinion. No, it's not a matter of opinion. There's a real reason one of these is right. So it's your job to figure out what makes them different. Because obviously they may look the same, but they cannot be actually the same. There must be a difference. So our job now is to just narrow our focus and really kind of think about what makes them different. So the first part isn't. He recounts a personal experience. True. He describes his own education. True. So that part doesn't interest me. That part's true for both. So what interests me is the ends. To illustrate a characteristic of the discipline of physics, or how physics has changed during his career. So let's go back. Let's contrast those two things. Something that's true of physics, or something that's changed about physics. Do you see it? These are kind of opposite choices, actually. At first, they look the same, but they're actually saying different things, right? One is saying that there's a thing that's just true of physics. That's choice A. And then choice B is saying something about physics has changed over his career. So let's think about continuity versus change as we reread this paragraph. Well, I wasn't around to witness the initial rejection of Higgs's proposal in 1964. Well, I was around, but only barely. I can attest by the mid-1980s, the assessment had changed, so we got change here. And that's his proposal. The physics community had, for the most part, fully bought into the idea that there was a Higgs field permeating space. In fact, in a graduate course I took that covered what's known as the standard model of particle physics, the quantum equations physicists have assembled to describe the particles of matter and the dominant forces by which they influence each other, the professor presented the Higgs field with such certainty that for a long while I had no idea it had yet to be established experimentally. On occasion, this happens in physics. Mathematical equations can sometimes tell us such a convincing tale that they can seemingly radiate reality so strongly that they become entrenched in the vernacular of working physicists even before there's data to confirm them. So notice I'm kind of underlining or highlighting two contradictory things. There's a lot about change, and then there's kind of a lot about just like a general characteristic of physics. And so that seems like there's evidence of both. So we really need to look at the differences and those specific words. Let's be careful here, though. In choice B, it's saying how physics has changed. All of physics, the entire branch of science known as physics, how has that changed? Well, what do they talk about changing? What's changed is the assessment of Higgs' proposal. Not everything about physics. Just this one little piece has changed. So here's the problem with B, is it's too broad. Yes, they talk about change. But the paragraph is talking about how physics has changed its opinion of Higgs's theory. Choice B, though, is saying that all of physics, the entire branch of science, has changed over the course of this guy's career. Too strong, too big. That's a problem. But look at A. He recounts a personal experience, we said that, to illustrate a characteristic of the discipline of physics. Let's try to turn that into a question. If we can answer the question, that's a good sign. What is the characteristic of physics? Well, the characteristic is that on occasion, a mathematical equation is so convincing that we believe something is true before we've proven it. So A is the right answer here. This is a really tough question. Absolutely is B a trap. 100% is a really good trap that they're laying for you. This is a tough question on purpose. They designed this to get you. But this is why when we do process of elimination, we're really forcing ourselves to examine every single word and phrase and really think about things that our brain wants us to ignore. We like things that match. And so our brain really gets excited when we have matching ideas. The fact that that word change is in both the passage and the choice is really, really exciting to our brains. But we have to fight that feeling, at least temporarily, and make sure that there's nothing else in there that might make that connection, invalid. And so that's what happens here is as we look at the choice in more detail, we see that it's going too far. It's not the right thing that's changing. Whereas A, we can make it fit. And one way that we can test a lot of these strong words and stuff like that is to turn them into questions. And if we can't answer the question, that's not a good sign. What is the characteristic of physics? It's that sometimes we believe things before we know for sure that they're true. How has physics changed during this guy's career? One particular theory went from being not really accepted to accepted. Notice how the answer to that question is not as good. And that's what makes choice B wrong and choice A right. Hopefully this helped. This is a tough one. Do the best you can. If you got it down A and B, you at least are on the right track. And this was a hard question. It happens sometimes. Just keep practicing and it'll get easier.